It has been way too long. I have now finally gotten a circuit that works, and well, it took me way too long. So here's how to build it. Parts you need: two 10K resistors, 150 ohm resistor, and a 1 mega ohm resistor, and a 100K ohm resistor, a 2.2 microfarad capacitor, or a 225, and then a bunch of 0.1 microfarad capacitors. You'll probably only need like 3 or 4, but they're to stop spikes from power supply stuff. So the chip I'm using is a LM2904. It's basically LM358, but better. So there should be a little notch, or even like a dot. Dot is pin 1, or the notch to the left over here is pin 1. You want ground. This is ground. Pin 4 is ground. Pin 8 is power. You just want to set it on your breadboard like this, or some other board you're using. Both of your 10Ks, put them next to where you have them. Keep them right next to where you are. Put one 10K on ground, and then to a point on the breadboard or somewhere else. You want it kind of near this part right here. You kind of want it. You kind of want it near. It doesn't need to be like super close, but it's just convenience. And then your second 10K from pin 8 or power to the same exact spot. It creates a 2.5 volt voltage reference, so the AC signaler can swing up and down and stuff like that. Okay, so next thing you would do is take your 100K, take it from the same spot as the voltage divider, so on a breadboard you put like one pin down. Connect it to pin 2. There you go. So 1, 2, pin 4, and then you make sure that the notch is up here, or the dot is here. Next thing you're going to want to add is your 1 mega ohm resistor. This is actually interchangeable, so you want to keep this part easily accessible, because this part will determine how sensitive the anemometer, along with the 150 ohm resistors. The lower the value of this is, the more sensitive it'll be, the higher the value. So if it's more than 1 mega ohm, it'll be much more sensitive, but it'll also have triggering problems. So you want to keep this around 1 mega ohm or less. And connect it from pin 1 to pin 1 to pin 3. Like that. Oh. Connected from pin 1 to pin 3 like that. So, there you go. And you can see the notch. Make sure you always have that correct. Next thing we're going to do is our input. So, our 2.2 microfarad, or 225 actually. I may have said it wrong. This is a 225 resistor, or 225 capacitor, or 2.2 microfarads, and connect it to pin 2. Connect it to pin 2. There we go. So you don't want anything of these touching, but there you go. Just want to make sure they're in the rows, because each one of these rows, like these rows here, are connected like this, but not like this. That's how it works. And they're not connected over this gap either. Now this is where, right here on this side, where it's not touching anything, you can see nothing's on this row. It's where the anemometer will be connected, and the other end of the coil to ground, or pin 4, I guess you could call it that. And if you have interference issues, you would connect right here on the same spot you connect a 2.2K resistor from here to another spot where the anemometer input would be here, 2.2K to here, and 68 nanofarads to ground. And that would make a filter about 1000 hertz to stop anything above what the anemometer would get up to ever. And next is our decoupling capacitors, which stop noise from making it through. So you want at least one of them, as close as physically possible to the power of the chip, like that. So you see one there, connect the other side of the capacitor to ground. And then, same thing for the voltage divider. If there is any updates, like I find a problem with something, I'll tell you to remove it in the description. If yours doesn't work, contact me through my Discord. I can try and help you. Same thing here to ground. Should stop most noise from making it into the thing. But if you still have noise problems, like you're using displays or something, you would just grab a bunch of these, and in a circuit you would just line them all up all the way on as many as you need to until the noise goes away, because it's most likely power rail noise. But if it doesn't go away, then you'll need that filter. If it stays there, then there's no noise, then it's fine. But if it stays there, you need that filter. Oh yeah, forgot the most important part. The 150 ohm resistor. Grab your 150 ohms. Take it from pin 3 and connect it to the voltage divider with the 210K, the same spot. There you go. And now, that's basically the entire circuit. And to adjust the sensitivity, you would lower this value to, well, anywhere from, if it's too sensitive for the anemometer you have, you would raise it up to 500 ohms, or maybe lower if it's not sensitive enough for you. But you don't want it too sensitive, it'll do false triggering. And you should keep this 1 mega ohm about the same as before. You don't want to raise it up any higher. So when you wind it, I recommend putting it like a foot or so. So you put this for here, you put that for there. It would go into the electrical box and stuff. That's good length for sure. Okay. Now I've got the new coil wound around. Take the little thing off. New coil. The method of doing it is taking these two wires, and you should always, I figured this out, I just remembered this, twist them together to produce interference. I'm just finishing twisting them up now, and it's just a tutorial. So then you put over one of these holes, and then you just put it through one of the holes. It should just fit right on there. Plus, you would probably want to put this in here first, but I'm doing stuff heavily out of order. That's more than enough, cable length. But here's one thing I did forget to do. Put this on. Put this piece on, make sure the holes here and stuff, whatever. I forgot you might have to sand it down. Yeah, you need to sand it down. There we go. Now we can start actually putting the coil down after you drilled the hole. There we go. Main part of this is that you would take your little wind direction encoder, sensor holder, and of course you put the propeller magnets from the last video on there, so I'm just going to show you the AC sine wave before I get to the circuit. And now you can try and fish your thing with a pair of tweezers to. So, once you get your coil wires out, you can use a piece of sandpaper, or you have to do this really quickly, but you could use a lighter. Like that. It's not charred, it's perfectly copper colored. There we go, there's our AC sine wave, except for it has something broken in here.